order 2, then we call it as a second order system. Okay, second order system, as we can see here, first order system and second order system, these are their very standard format. So tau is named as the natural period of oscillation, xi is the damping factor, and kp is the steady state gain in the second order system in the mathematical format. In the yesterday's class, we have derived the equation for the transfer function of YouTube manometer, in which what was the output? What was the output in the YouTube manometer? What was the input? What was the output? Output was?
So like input is height difference, output is height difference, input is pressure P1.
Yes. Because of the pressure, the height is changing. Therefore, because of what it is changing, that is the input, means something changing from surrounding on the system. System's parameter is changing because of what? Because of the pressure. Pressure is coming from the outside. Okay, from the outside or from the surrounding. If my mercury U2 manometer or the liquid itself in the U2 manometer is a system, then the pressure is coming from the surrounding on the system. So it is an effect. It shows the effect of a parameter, a variable, which is affecting, or the its impact is from the surrounding on the system. And what is the output? Output is nothing but because of that height is changing. Okay, so something, it is going the information out of that system, that is the height has been changed. So the h is the change in the height in the liquid. So that was the output. So at last we have identified this equation. So this equation, h by delta ps is equal to kp by tau square s square plus 2z tau s plus 1. Similarly, another example for the second order system. Okay, let me tell you again, these are nothing but the equations. These are nothing but the second order examples. They are inherently second order system. Inherently means they are working on F is equal to ma format. F is equal to ma, Newton's law of motion. F is equal to ma, where a is a second order differential equation of h, that is the displacement. So itself represent that d2y by dt square, okay, like that. So the change in momentum, okay, rate of change of momentum is a second order differential equation. So the system is second order system. Okay, already we have identified the multi-capacity system is behaving like a second order system, because there is a, in the denominator there are two brackets, separate brackets. Okay, so we have already discussed that thing. Now the next step is, okay, this is the derivation of the previous one, that is the damp oscillator. Now the next step is, उसके बाद हम क्या करते हैं कि once you get the transient response, that is the transfer function, now we will discuss the transient response. कि भाई this equation is there, that is the y by xs is equal to 1 upon tau square s square plus 2 z tau s plus 1 is there. Then what will happen if xs is a step change, xs is a impulse change, is a sinusoidal, or it may be a linear, then how that yt will behave, how that profile of yt you will get. Okay, so why we need to study all these things? Because the to identify its to achieve the objective of the control system. Okay, as we have already defined that the objectives of the control system is to suppress the external influences. Okay, the second is to keep the system at steady state, or the at the stable condition, and the third one is to optimize. So out of these three, okay, there may be possibility that single purpose is important, or multiple purpose simultaneously we can perform with the help of control system. Okay, so likewise, how that yt will behave if there is a change in excess imposed into the system. Okay, so we call it the response of second order system. So we will start the new topic, response of second order control system. Okay, is this Visible? Response of second order control system. Is this visible?
Yes, sir.
Yes, sir.
ओके तो अभी इसमें क्या करना है हमें वेरी हमने ट्रांसफर फंक्शंस तो हमें मल्टी कैपेसिटी का भी निकाल लिया देखिए देयर वेयर थ्री केसेस देयर वेयर थ्री केसेस वेयर वी हैव मल्टीपल that is the higher order systems okay higher order systems so one was the multi capacity हमने इसका डेरिवेशन किया है ना इंटरेक्टिंग नॉन इंटरेक्टिंग का तो यू ऑब्जर्व दैट इट इज अ सेकंड ऑर्डर सिस्टम है ना लाइक दिस ओके एंड देन इनहेरेंटली सेकंड ऑर्डर F इज इक्वल टू एम ए हमने यूट्यूब मैनोमीटर का किया है और डैम्प ऑसिलेटर का किया है इसका भी अब रही बात सिस्टम विद कंट्रोलर हम डिस्कस करेंगे इन वेरी ब्रीफ बिकॉज there is a controller ना controller क्या होता है एक लॉजिक होता है it is nothing but a logic it is a logic it may be a summation it may be addition it may be a subtraction it may be a division it may be multiplication it may be any law means it may be a different laws are there just like y is equal to mx plus c y is equal to mx so we call it as just like a law कि straight line का equation क्या है if it is following y is equal to mx plus c law then it is a straight line with the intersection and with the slope like that way okay so it is a law so something law means something like that the proportional action it may be inverse proportional it may be directly proportional so these laws a plus b gives c okay whatever a will be there whatever b will be there it will give c as the addition so that plus sign is a law so likewise तो कंट्रोल सिस्टम जब हम करते हैं ना सिस्टम विद कंट्रोलर मींस इट रिप्रेजेंट दैट कि मेरे पास सिंगल फर्स्ट ऑर्डर सिस्टम है अगर मैं कंट्रोलर डालता हूं तो ओवरऑल जो होगा इट विल बी अ हायर ऑर्डर ट्रांसफर फंक्शन okay that means though it is my process is first order but implementations of the control strategies control configuration will make that whole system at higher order of the higher order so we will discuss later because the controller logic control laws are itself the part of study okay so we will discuss later so two we have covered multi-capacity process and inherently second order system now what we will do we will use we will go for the responses so let me tell you responses before to move on this thing how it will behave so let's discuss about the things which we have studied earlier and the information from the previous lectures previous study how we can implement over here okay so let's see we have already discussed that we have already derived the equation gs is equal to ys by xs is equal to 1 upon tau square s square plus 2z tau s plus 1 okay now consider the response means what actually क्या होता है कि जैसे हमने बोला है ना कि there are two ways to study the responses one is the experimental method another one is the mathematical method the experimental methods में क्या करेंगे हम experimental methods में क्या होता है कि deliberately we impart the change into this system into the input जैसे केमिकल रिएक्शन करना है बार बार हम केमिकल कॉन्सेंट्रेशन इनपुट के जो हमारा इनपुट रॉ मटेरियल है उसका कॉन्सेंट्रेशन चेंज करेंगे और आउटपुट का कॉन्सेंट्रेशन आइडेंटिफाई करते जाएंगे सो डेलिबरेटली वी आर चेंजिंग बट every time we need to purchase the chemicals we need to prepare the solutions and we need to run the experimentation so it is a what we call the time consuming and it is a it needs a more manpower so it is something what we call and always the profit is calculated based on all these things. So mathematically क्या है कि we assume that it will follow this particular mathematical law and the same thing we replicate into the numerical format. Okay, so there is no loss of chemicals or the investment is not required in that case. So similarly इसमें क्या कर रहे हैं हम in the response of second order system में भी हम क्या consider कर रहे हैं कि there is some change which will follow the step change type of thing okay but before to move on that just observe the equations these equations represent that in the denominator it is a quadratic expression so we can represent it like a s minus p1 s minus p2 okay forget 1 upon s at present अब मुझे बताइए देखिए ys is a function of tau तो कांस्टेंट है किसी भी सिस्टम ओके एक सिस्टम मैंने इम्प्लांट करना है एक हीट एक्सचेंजर बोलो या फिर एक मिक्सिंग टैंक बोलो या फिर एक लेवल टैंक बोलो, जो मैंने फिक्स करना है तो मैं फिक्स करूंगा उतने कैपेसिटी का। ठीक है, तो उसका टाउ स्क्वायर तो कांस्टेंट रहेगा, उसका टाउ स्क्वायर भी कांस्टेंट रहेगा। अब रही बात द क्वाड्रेटिक एक्सप्रेशन, okay, so quadratic equation is comes in this particular fashion: s minus p1 and s minus p2. What are the p1 and p2's represent? What are these values? What do you understand? What actually the p1 and p2 stands for? These are the nothing but the roots or the solution of that quadratic expression, which will satisfy this quadratic expression. है ना? P1 and P2. Now the concept is that P2 will decide the nature of yt, because y is a function of P1 and P2 now. Are you getting my point? समझ में आ रहा है?
Yes, sir.
ठीक है, y is a function of P1 and P2 now. अब P1 and P2 will decide what yt you will get. ठीक है, अब irrespective of any change, let me tell you, ठीक है, फिलहाल at present that P1 and P2 will decide कि what particular yt you will get. अब P1 and P2 क्या क्या हो सकते हैं? P1 and P2 क्या क्या हो सकते हैं? P1 and P2 नेगेटिव भी हो सकते हैं, P1 and P2 पॉजिटिव भी हो सकते हैं, P1 and P2 कॉम्प्लेक्स भी हो सकते हैं, P1 and P2 इक्वल भी हो सकते हैं, P1 and P2 नॉन रियल भी हो सकते हैं. Let's see. Are you getting my point? Are you getting my point? Okay. P1 and P2 कुछ भी हो सकता है. So let's see how P1 and P2 affects the yt. So generally क्या होता है? Why we are taking this thing P1 and P2? If you observe that, P1 and P2 here, मैं इसको कॉपी करता हूँ. Is this visible?
So we can see the PPT.
Okay, one note is not visible.
No, sir.
Now, is this visible?
Yes, sir. Now it's visible.
Okay. Now, see here. Actually, when we say the quadratic expression is our tau square s square plus 2 psi tau s plus 1. Okay. When we equate it equal to 0, that time you observe that P1 will be minus psi by tau plus under root psi square minus 1 by 2 by tau, sorry, 2. It is not 2, it is tau. It will be tau. Similarly, P2 will be plus psi tau, no, minus psi tau minus of psi square minus 1 by tau. है So this will be a very simple format of our P1 and P2. ठीक है? Minus b plus minus under root b square minus 4ac by twice a. है ना? रूट्स। देखिए मैंने पहले क्या कहा था कि y will be the function of p1 and p2. Now here p1 and p2 are the function of psi. What is psi? Psi is nothing over damping coefficient. What is psi? Damping parameter. Psi was my damping factor. Psi was damping factor. Is this visible? ठीक है, देखो y पहले p1 p2 का फंक्शन हो गया, but p1 and p2 are depends on value of psi. So ultimately जो y रहेगा it will be function of psi, and psi will decide how that y will behave. Any doubt? Is this visible? Any doubt? Mathematically we are just correlating the things, okay, and then we will implement in the actual examples. ठीक है? So now if you observe in this particular equation, the actually psi we can compare it with the 1. This will decide. Okay, so what will happen? What will happen if psi is equal to greater than 1? What will happen if psi is equal to 1? And what will happen if psi is less than 1? Because ये जो ys रहेगा हम इसको क्या करेंगे, इन्वर्ट करेंगे, इनवर्स लाप्लास लगाएंगे, so it will come into the yt format. Okay, and that yt expression will depend on the psi, whether psi is greater than 1 or psi is equal to 1 or psi is equal to less than 1, is less than 1. This will decide the p1 and p2. Okay, and its nature, p1 and p2 nature, and then the combined effect will give us the nature of y, nature of out. समझ में आ रहा है? नेचर ऑफ आउटपुट किस पर डिपेंड करता है? p1 एंड p2 के नेचर पर. ओके, एंड p1 एंड p2 किस पर डिपेंड करता है? psi पर. और psi किसके साथ कंपेयर होगा? 1 के साथ. आर यू गेटिंग माय पॉइंट? एवरीबॉडी? है ना? नाउ so let's on your ppt. So the value of psi when it is greater than 1, the p1 and p2 you will get two distinct and real poles. क्या होगा? देखो p1 and p2, you just substitute the values over there, you just substitute the values. यहाँ substitute करो, greater than 1 डालो, say it is 2, 4 minus 1, यहाँ डालो as a 2, यहाँ डालो as a 1, यहाँ डालो as a 1 के नीचे, so 0.8 डालो. You observe that. देखो very simple is, यहाँ 2 डाल देता हूँ, 4 minus 1 will be 3, under root 3 by tau. psi कितना है यहाँ? 2 है, -2 plus 3. ठीक है, जो भी कैलकुलेशन आएगा, बट इट इज ऑब्जर्व दैट कि ये इमेजिनरी नहीं रहेगा. it will be a real pole. क्या रहेगा? It will be a real pole. It will be a real pole. Are you getting my point? दिख रहा है?
Yes, sir.
ठीक है? ये यहाँ आ गया. Now, when we put xi is greater than 1, simply 2, so it will be the real one. Similarly, in P2 also substitute xi is equal to 2. ठीक है? It will also the real one, but with the negative side. Okay, so the nature of roots will be a two distinct and real poles you will get when xi is greater than 1. This particular condition is called as overdamp condition. This condition is called as, what we call it as a overdamp condition when damping factor is greater than 1. Damping factor is greater than 1. ठीक है? और इसका जो नेचर होता है रिस्पांस का, that response is नॉन ऑसिलेटरी. ठीक है? वहां ऑसिलेशंस नहीं होते. ऑसिलेशंस क्या है कि इफ इट इज ऑसिलेटिंग अबाउट इट्स about any value, oscillations, okay, about some position, so it is non-oscillatory. Now substitute xi is equal to 1, okay, 1 minus 1 0, okay, will get cancel, 1 by tau will be there. Here also this term will go vanish, 1 by tau will be there. What will the nature of the roots? Real and equal. तो 1 by tau सब दोनों तरफ मिल जाएगा. P1 भी 1 by tau रहेगा, P2 भी 1 by tau रहेगा. They are real and equal. That time the response will be critically damped. That response will be critically damped. Are you getting my point? Students, उस रिस्पांस को क्या कहते हैं हम? क्रिटिकली डैम्प. क्या कहते हैं? क्रिटिकली डैम्प. ठीक है? अब जस्ट कोरिलेट इट विथ our these equations for the interacting or non-interacting equations when they are in series. See here, tau 1, इसका इक्वेशन क्या, इसका रूट क्या निकलेगा? s is equal to minus 1 by tau 1. ये s1 करता हूं मैं, और दूसरा आएगा s2 is equal to 1 upon tau 2 माइनस, है ना? इसका, इसके रूट से इट इज p1, से इट इज p2. These two are different, 1 upon tau 1 and 1 upon tau 2. They will different, okay, and real. Then that time when two distinct and real poles will be there, then system is behave like a overdamp system. It will be non-oscillatory. And same thing we have discussed कि non-oscillatory है, इसका मतलब it will behave like a, ये थोड़ा S shape होता है जब वो सीरीज में होता है. Are you getting my point? टाइम ज्यादा हो गया क्या रे? What is the time? आपका क्लास है? स्टूडेंट्स?
No, sir.
ठीक है, एक लास्ट, when xi is less than 1, what will happen? So if it is less than 1.8, तो अंडर रूट में निगेटिव साइन आ जाएगा. जस्ट रिस्पॉन्ड. निगेटिव साइन आएगा. एंड जब अंडर रूट के अंदर निगेटिव साइन आता है तो इट विल गो इनटू द कॉम्प्लेक्स नंबर. Okay, so the nature of roots will be complex one. Are you getting my point? Complex. And जब complex आता है तो that time its nature will be oscillatory or underdamped. देखिए, रिस्पॉन्स जो हमने यहाँ लिखे हैं, नॉन ऑसिलेटरी, क्रिटिकली डैम्प, ऑसिलेटरी, अंडर डैम्प, ये क्या है? ये आर द क्वालिटेटिव वे आई एम डिस्कसिंग ओवर हियर, बट वी कैन डिराइव इट. And after derivation, observe that there are some terms just like sine, periodic functions. This gives us the oscillations. So you observe that when psi is overdamped, when the system is overdamped, when psi is critically damped, that time sine terminology will not be there. Anything else? What? किसी को कुछ कहना है? ठीक है, very simple thing is there. Okay, we can derive it. But right now, what the concept is that you just identify कि हमें y is depend on roots of quadratic expression which is in the denominator, and the roots of quadratic expressions are nothing but the function of xi, that is the damping factor, and damping factor have to be compared with the need to be compared with the 1. Okay, so 1 greater than 1 अगर है तो overdamp रहता है, equal to 1 है तो we call it the critically damped. If it is less than 1, we call it as a underdamped system. Okay, and the natures are overdamp का non oscillatory है, critically damped का भी non oscillatory है, while when the less than 1 the roots are complex, it will give us oscillatory nature. Oscillatory nature. Are you getting my point? Another thing I would like to add is this कि जैसे हमने यहाँ नॉन इंटरेक्टिंग टैंक का देखा है. Okay, tau 1 and tau 2 are different. Okay, they always follow, it may be a overdamp always, or it may be a critically damped. Remember, tanks in series, first order tanks in series, first order system in series always gives us the overdamp or the critically damped response. It will never give the complex one. Oscillatory नहीं मिलेगा. Oscillatory नहीं मिलेगा. Okay, we will observe that कि oscillatory कब मिलता है. But right now, today we will stop here. If everybody is comfortable about this particular value of psi, any question regarding this? Okay, ये हमें qualitative discuss कर रहे हैं, because after that to study this thing response, it is very much important कि actually psi क्या करता है. कंट्रोल सिस्टम जब कंट्रोल करना है ना तो हमें psi को कंट्रोल करना पड़ेगा कि भैया उसको ऑसिलेटर में लाना है या नॉन ऑसिलेटर में लाना है. Are you getting my point? What will be the further step? हमें कंट्रोल करने के लिए, जैसे फैन की स्पीड हमें कंट्रोल करनी है तो हमें कुछ तो भी तो एडजस्टेबल चाहिए ना, कुछ तो एडजस्ट करना पड़ेगा भाई, है ना. तो लाइकवाइज व्हाट वी कैन एडजस्ट, द एडजस्टमेंट इज लाइक दिस कि मुझे झाई को, वी विल डिस्कस दैट थिंग कि झाई को एडजस्ट करना है क्या है, हमें पोल्स को एडजस्ट करना है, तो मैथमेटिकली विल डिस्कस दैट. ठीक है, तो टुडे वी विल स्टॉप हियर. Hope everybody is simple. I have explained whatever thing, and this information we needed in the next lectures. Okay, so we'll stop here today. Any questions?